Hello again. We are on our last lesson of this unit. This is lesson 11.7, and we're going to talk about where these functions meet or intersect on a graph. So let's get started. We're going to talk about an example. Solve the following system. There's my graph there. The first equation is y equals x to the fourth plus x minus 1, and there's the graph of that one. And the second one is y equals x cubed minus 3 to the x plus 3. So I've thrown some exponential functions in there as well. So I can see both graphs. I can see that they cross at two places, but what are the coordinates of those two places? So I graph them on a calculator and I find the points of intersection. My calculator is going to tell me that one of them is at negative 1.3 and 0.561, and the other point of intersection is very simply at 1, 1. Okay, so that's how you find them. Now here's a trickier example that I wanted to go through with you, kind of at the level of test questions that you might be asked. Find all values of k such that x cubed minus 3x squared equals k, such that that equation has three separate solutions. Okay, so kind of hard to figure out how to do that one. So what I'm going to do is I'm going to graph the left-hand side on a calculator, and that's the graph that I get. And I'm going to break this down and see which y values will give me one, or which k values will give me one solution, which will give me two, and which will give me three. All right. So I know that y equals k. That's the right-hand side. That's just a horizontal line that can travel anywhere across the entire graph. So I want to see where that horizontal line crosses that blue curve, and I want to see how many times it crosses. All right, so let's look at how I'm going to do this. If I draw a line that goes through that maximum at the origin, then there's going to be exactly two solutions. There's two places where that horizontal line crosses the blue curve. So I don't want that point. And if I draw it anywhere above the maximum, then I'm only going to get one solution. So you can kind of see as that vertical or as that horizontal line travels up or down that curve above, you know, kind of in that red shaded area, I can only cross the curve exactly once. Okay, so now let's talk a little bit further. If I draw the line that goes through that minimum, that valley, where x equals 2, again, I've got two solutions. And if I draw that horizontal line anywhere below, in that red shaded area again, I'm only crossing the blue curve once. So I don't want any of those situations. Let's look at what I haven't considered yet. Okay, if I draw the line anywhere between the maximum and the minimum, so you see that green line there, it's crossing the curve three times, and no matter where it goes, higher or lower than where I originally drew it, there's going to be three solutions. As long as I don't reach the maximum or the minimum on that curve, that's what's going to happen. Okay, so I need to figure out where that maximum and where that minimum is. I know the x coordinates, but I actually need the y coordinates because my horizontal line has a y value. So the maximum occurs at 0, 0. The minimum occurs at 2 and negative 4. So the y values are what I'm interested in. So that means k can be anywhere between negative 4 and 0. Those are the boundaries of the y values. Notice that it can't equal negative 4 and it can't equal 0. So that was kind of a tricky example of how to do that kind of a question. If you have any questions, please let me know, and I will see you tomorrow.